Hello, my name is Robin Kay, and I'm from Ontario Tech University. And with my colleague, we did a study examining the creation of video podcasts to improve the quality of mathematical explanations for pre-service teachers. So, the context or the bigger picture is that pre-service teachers in mathematics have considerable difficulty explaining how to solve mathematical problems. And there is limited research on this essential skill. So, what we decided to do is have the students create video podcasts using tablets and Camtasia. So, they used tablets to solve problems in an analog way with writing and step by step procedures. And then we looked at the quality of the explanations and assessed them. So, our main research question is what are the strengths and challenges that pre service mathematics teachers display when creating video podcasts for grade 7 and 8 mathematics content? The participants were 37 pre service teachers, 26 female, 11 male. All pre-service teachers specialized in the teaching of mathematics from grades 7 to 12, and English was the second language for a third of the participants. So, to begin with, all the pre-service teachers were trained for 2 hours on how to use the software, the tablets, the hardware, and Camtasia to create video podcasts. And then they were given a set of detailed criteria to help guide their creation of these podcast explanations. They had 3 to 4 weeks to develop 4 to 6 minute math podcasts. So, based on the work of Kay in 2014, we looked at 4 aspects of the video: the context created, the quality of the explanation, the cognitive load, and engagement. Specifically, we used an instructional video evaluation scale. So the extent to which an instructor established context was assessed by 3 items. How they created effective explanations was assessed by 7 items. How they minimized cognitive load in the person watching the video was assessed with 4 items. And finally, how they cognitively engaged students was assessed by 5 items. Each of the items were assessed on a 3 point scale of no, whether the item was not addressed, or sort of, which was 1, or yes, the item was addressed. So in terms of context, almost 70% of the students were able to develop context and correctly articulated the problem being addressed. 60% identified key elements of the problem and explained them. And then about half the students gave a clear problem label for the mathematics content that they were addressing. In terms of explanation, almost 2/3 of the students showed all the key steps. 60% of the students explained the reasoning behind each step and used the correct mathematical conventions. About half the students used an appropriate strategy to solve the problem and offered tips for solving the problems. Only 2 out of 10 students offered visuals to support explanations, and about 3 out of 10 students noted potential errors that might be made when solving the problem being discussed. In terms of cognitive load and minimizing cognitive load, 8 out of 10 students provided a clear, organized layout of the problem. About 50% of the students provided writing that was readable, and visually highlighted key points in their explanation. And less than a third of the students listed supportive elements, such as terms or formulas, when solving a problem. In terms of engagement, cognitive engagement, about two-thirds of the students were able to limit distractions when explaining their problem. About 6 out of 10 students went at an effective pace for learning. That means that they weren't too slow and they weren't too fast. Half the students had a clear voice, and half the students provided an appropriate length of an explanation. Finally, just under 50% of the students used an engaging conversational voice. So, in terms of opportunities for growth for pre-service teachers explaining mathematics problems, in terms of content, they should be encouraged to grasp and understand the big picture of a problem and articulate that big picture when they're explaining a problem. So, putting a problem in the proper context as opposed to an isolated problem that is not connected to anything. In terms of explanations, in pre-service teacher programs, more time should be spent explicitly focusing on the connections between problem solving within the problem solving process and making thinking explicit. In other words, these students have an automatic understanding of the problem and they have to reverse engineer their understanding and make their thinking explicit to the students, new students who are trying to learn these mathematical concepts. In terms of cognitive load, if you're using an analog pen or writing, it has to be readable. If it isn't readable, that can increase cognitive load for students. You need to highlight key points so students know what you're focusing on. That's particularly important for videos. And you need to write down key elements so students don't have to hold formulas and key terms in their head while trying to understand the explanation of the problem. And finally, with engagement, a conversational, personalized tone, as opposed to a teacher voice in front of the classroom, will probably work best. If you have any questions, please contact me at this email address, Dr. Robin K., or you can contact Dr. Robin Ruttenberg Rosen at this email address.